first, we have this equation for critically damped motion, and this is the illustration of the problem. We must know the value of A and B to solve the problem. At t is equal to 0, x is equal to 0. And so, if we substitute t is equal to 0 to the equation, we get a plus b times 0 times e raised to beta times 0 is equal to 0. And we get that a is equal to 0. And now we get the velocity. We get the derivative of the equation of critically damped motion. But we know from earlier that a is equal to 0, and so we just derive this equation. And we get b times e raised to beta t minus beta times b times t e raised to negative beta t. And so we know that the velocity at t is equal to 0 is just the initial velocity, and we get this and substitute t is equal to 0 to the equation, and we know that the initial velocity is equal to b. Now we know the value of a and b, and we substitute it to the equation, and we get x of t is equal to v sub 0 times t e raised to negative beta t. And now for letter b. We know from earlier that at t is equal to 0, x is equal to a. But now, since the initial position of the cart is not at 0, rather it is at x sub 0. And then we get the derivative of x to get the velocity, and the derivative of the equation is this. Now the initial velocity is just equal to 0 since the cart wasn't pushed or kicked, and so we substitute t is equal to 0 to the derived equation, and we arrive to this: b minus beta a is equal to 0, and then b is equal to beta times a. And we know from earlier that a is equal to x sub 0, and so b is equal to beta times x sub 0. And now we get this equation: x of t is equal to x sub 0 plus beta x sub 0 t times e raised to negative beta t, or x sub 0 quantity 1 plus beta t times e raised to negative beta t. And at t is equal to 2 pi all over w0, we know that since this is a critically damped motion, w0 is equals to beta, and so we get 2 pi over beta, and we substitute that to these equations, and then we get this: x of 2 pi over beta is equals to x sub 0 plus 2 pi x sub 0 times e raised to negative 2 pi, or x sub 0 times quantity 1 plus 2 pi times e raised to negative 2 pi. And then this is the graph of both a and b. Since a started at the equilibrium point, and then it was kicked, and so it was displaced, and then since it is a critically damped motion, it quickly went back to the equilibrium state. And for b, since the starting position is not at the equilibrium position, we started not at 0 but at x sub 0, and then it goes down quickly to the equilibrium position.